number 3. Now remember, this is what we call kinematics, and there are 5 variables on the kinematic equations, okay? So let's take a glance at these kinematics on question number 3. It says Marissa car accelerates uniformly, okay? So she's speeding up at 2.6 meters per second square. So I'm going to go ahead and I'm going to, this is the notes. Here's Unit 2 notes, and I just turned it one page to page 3. Question 3. So here, Marissa's car speeds up, and this is her acceleration. It tells me, or it asks me, how long does it take, question mark T, for Marissa's car to accelerate from this speed, VI, to this speed, VF? Well, again, for kinematics, we have 5 variables, VI, VF, T, A, and distance. Now, I'm knowing that we're going to use these again in just a moment. I wanted to practice. So here, they gave me the VI of 8.85, the VF of 9.65, A of 2.6, T is question mark, and distance was never even used. Our kinematic equation states or asks, number 1, was distance ever talked about, used, discussed, or looked for? And for this situation, the answer is no, it was not. So it says, let's use the easy, bless you, cheesy equation of acceleration. Remember, we have 3 originals. So let's use this one. Okay? First step.
So distance is never talked about
at all. I agree. Since distance was never talked about at all, I agree 1,000%. So it's going to be this one, but let me double check. A, VF, VI, T is my question mark. So algebraically, you can solve for this. And that's what we're going to do today. We're going to do algebra again, but we're going to do this in the X and Y with 8 variables. But I want us to ease into that. Let's go ahead and let's put this in.
8 variables on the quiz?
There's going to be 1 question with 8 variables on the quiz. The rest are going to be like this for the quiz. All right, we got this. We got this. 2.6 equals 9.65. Take away 8.85 over, well, I don't know the T. Algebraically, I'm going to multiply by T to cancel that. Multiply by T, that's not going to work. Divide by 2.6, cancel. Divide by 2.6. T equals 12, is that what somebody said? 9.65, take away 8.85 equals, divide by 2.6. 0.3, and I'm going to round 0.31 seconds. Not too bad? Do it one more time. Yeah. So here, what I did was I wrote out this equation and I filled in the variables. 2.6 belonged here, 9.65 was here, 8.85 was here, T was unknown. I multiplied T to cancel out on both sides, but T times 2.6 is not going to cut it, so I divided by 2.6 on both sides. That way I canceled it out and got T by itself. Okay.
Okay.
Now, let's go ahead and question number 6 is going to be on D2L once I post it, because this question we did earlier today for the 8 a.m. class. So you can watch the video and you can practice this one on your own, and I know I did it for you on the video. I'm going to turn the page though. And let's talk real quick as a reminder. We wrote our notes in for the word free fall. Free fall is anything that is no longer sitting on a desk, on a table. So if I have an object that I want to toss up, toss it up and I catch it, that's free fall. I throw it, that's free fall. I drop it, that's free fall. I go and I kicked it. All of those are free fall. So can we recognize that free fall is anything in the midst of the air? Okay, one more time. Free fall is anything in the midst of the air. Now here's the next way, or the next way to think about it. Free fall is subject to gravity. Like, I'm falling, and gravity's pulling me down. But it's not just gravity on Earth, because there's going to be some questions where you're going to have to figure out gravity on the moon, or gravity on a different planet. It's gravity anywhere. All planets have gravity. So, one more time. Free fall is in the absence of air resistance. Yes, we breathe air, but we are going to ignore this because this is our first basic physics class. Some of you want to be pilots. You want to go into engineering. This is a great class to get your fundamentals of physics. Free fall is in the absence of air resistance, unless later on when you go to more advanced physics. But at this moment, it's subject to gravity. It's falling and gravity is pulling it down. Okay? Now that we said that, we came over here and we talked about this. For an example, when we had this gun and this kid shot this gun, a bullet came out and it formed a parabola. If we cut this parabola in half, we had two vectors that were working against each other. Go ahead and say it. Ms. Munson, you're right. We should have canceled the lab. Look at that. I know. Mom's always right.
It's raining, you don't keep it.
Pouring down rain. That's why we canceled the lab till Friday. Here we go. So my object or my bullet was going against gravity, so I have two vectors in the opposite direction. But when it came down on this side of the parabola, the two vectors were in the same direction. The cool thing here is we have this top location called non-zero acceleration. This is going to be key in just a moment. One more time. Because everything we do is building upon itself. One more time. We have the top peak of a parabola, and it has a name, non-zero acceleration. That means at the location, I know two variables. Number one, gravity. Gravity's pulling down on it at negative 9.81. Now that's Earth's gravity. That is not the moon's gravity. That's not Jupiter or Mars's gravity. They have their own gravity now, okay? But here on Earth, it's negative 9.81 because it's moving down. The other number that I know that's going to help me in a moment is that the velocity at that location is 0. It's 0. Now we need that information for what we're about to do. So let's go ahead. Again, I'm still easing into what we're about to do. Now, today, our math equations, this is going to be on the quiz, Pythagorean, okay? Now, this gets my students confused because in a moment we're going to do drawings and you're going to see a right angle. Now, if you have two legs trying to solve for the other leg, you're going to use Pythagorean. Yeah, I understand. And there you go. And we talked about, well, the triangle. Now, some triangles here that are right angles, you should know now how to label the hypotenuse, the opposite, and the adjacent leg. And from that, we need to remember, am I in the correct mode, as in degrees? If I'm not talking about a degrees like this, then I need to be in radian or rads. Okay, keep that in mind. Now, if I'm talking about an angle, I'm going to use SOHCAHTOA, the sine, the cosine, or the tan. Let's practice one of those. It's not what we're doing for today's math, but let's practice it. Because this SOHCAHTOA, I guarantee you, is going to be the core of our quiz in 2 days. So let's practice this. Let's go to this question right here. This is the core of our quiz on Thursday. How fast must a truck travel, okay, to keep under an airplane that is flying at a velocity or speed of 105 kilometers per hour at an angle of 25 degrees to the ground? If this is the ground, and we do know the angle, here's my airplane. My airplane is going to fly, let's see. you don't have to. I do, because it helps me. Here's my airplane.
Airplane's got a big forehead.
Oh, here. So that way you can see there's the pilot. They're flying up. And so my airplane.
You forgot the window.
Oh, sorry. There we go. There we go. There's my airplane. And it's flying up at an angle of, remember last week, what did I say? Where is the angle located? It's always located at the tail end of the arrow. So this is the tail end of my arrow. So that is going to be my angle. My angle of elevation or angle up is 25 degrees. This airplane is traveling at 105 kilometers per hour. There's a truck. I don't know, maybe this is like a stunt guy on one of the movies or something. But there's a truck down here. And this truck is trying to travel and drive. What is the velocity of this truck? How fast does it need to drive? That way when the airplane is flying up, the truck is driving this way and it maintains the speed. It has to maintain under this airplane. It's taking off. The truck is about to drive. Like that, at the same speed, well, at the same location, but I don't know what this vector arrow is. I personally can come over here and say, hey, look at this. If I draw a line right here, now I see a right angle. This page is crucial and helpful when it comes to quiz this week. I can come over here and I can call this hypotenuse. If this is my theta and right angle, adjacent, opposite.
Wait,
Mhm.
the adjacent touches the angle and
The angle and the right angle is the adjacent leg. And then the opposite is the leftover.
Wait, this is so let me
Okay.
so we can just tell it?
Well, let me highlight. Remember last week I was highlighting? Let me highlight what I have
Have the H,
and what am I looking for?
A and the O.
Uh-uh.
No. Oh. A.
A. So who is A and H?
Oh, God.
Ka.
So it's the ones we have that we.
Yep.
I thought it was the ones that we don't have.
Ah, okay. Okay. So we have the H, check. I'm looking for the A, and I have the theta of the cosine. So this is my equation. The cosine of the theta equals the adjacent over the hypotenuse.
Do we have to remember?
No, good call. Let me pull up the formula chart for you.
I always had a formula chart come out because I do F.
Look at this formula chart. SOHCAHTOA. Look, the cosine of the theta equals the adjacent divided by hypotenuse. The adjacent divided by hypotenuse. So you do not have to memorize it. It is on the formula chart. So the cosine, oh, wait a minute, are you in degrees? Go check. 25 degrees equals, I do not know adjacent, but the hypotenuse is 105.
How do we know if we're in degrees?
We go back to mode up here, click on mode. And since it's darkened for degrees, that is correct. Click clear. The cosine of 25, you do it, I'll do it. Because I'm going to do this step by step. It's 0.9, round up to 1. Multiply this side by 105, cancel. Multiply this side by 105. The adjacent leg, or the speed of the truck, needs to be 95.16. Use the same units.
Kilometers per hour.
That's it. This is what our quiz is going to cover. Let's try it again. Yes, sir. How do I know that's the hypotenuse? Because I made this into a right angle. And so if this is my right angle or my 90 degrees, when I draw an arrow from here, the leg that the arrow touches, just like when we did this, if that's my right angle, the arrow of that leg touches is the hypotenuse leg. So I made the right angle, and that is the hypotenuse leg.
Like, I think he's saying, like, how did you know to put 105 right there instead of on the
Because the airplane's moving at that, if this is the airplane's line,
Airplanes only really move.
the airplane's moving, here's the line that the airplane's moving, that line is 105. Because this line belongs to the airplane. This line belongs to the truck. Let's try it again, because
Let's try it again.
this is going to be our quiz for this week. Oh, okay. I'm going to pause it.
Wait, no.
I'm going to pause it.
They don't give us many stuff. Oh, wait, never mind.
Can we do a different one by
They don't give
ourselves?
us
This
many.
one?
Whoa. It does have numbers. It's talking about the airplane from the question
That's what
above.
I'm saying. Oh.
Uh-huh. So you do this one.
Oh.
I'm working this one, you work this one. What is the magnitude of the vertical line from the airplane from the question above? What's the vertical line?
I got mine. The
Opposite leg, which is up and down. Go ahead.
But how are you supposed to know that?
I'm looking at
Oh, you know it. There's two ways to do it. I'm going to do it both ways. I'm going to call it number one. I'm going to call it number two. There's two ways to do this. I'm not going to tell you which way to do it. Da-da. Mhm.
We already have it.
Okay. Okay, let's see. Subtract.
That much.
Okay, 1969.57. Second cube. Did you say a bad word while my video's going?
Okay, does A
Whoa,
square minus
whoa,
B
whoa,
squared
whoa,
plus
whoa,
B squared
whoa.
sound what? I didn't say plus B squared, you liar. Does A square minus
Whoa.
B squared sound like anything? Okay, take this. Does C squared minus A squared equal B squared?
Okay, I did it two different ways and I got the same answer. Y'all ready? All right. First, I'm gonna.
Whoa.
Okay, first thing is, here are the two ways you can do it. You can go either one or you can go two. Now, it didn't have to be TOA. It It could be, the sign. And you could use sign
Oh, you can
instead of TOA. I just used TOA. I needed to use something that had the O leg. So let's take a glance and read the equation. What is the magnitude of the vertical component? Look up here. I know this angle, or I know this leg. This is the horizontal component. This is the vertical component. I found the horizontal right here. The vertical is what I'm looking for. What is this leg? Well, there's two ways to do it. You can use the SOHCAHTOA or you can use Pythagorean. Let's look at SOHCAHTOA first. If I SOHCAHTOA, I can choose SOHCAHTOA. Well, if I'm looking for the O leg, I can either use the sine or the tan because those two include the O. Does that make sense? I just picked the tan just because I did. I had a 50-50 shot. I can use either one. They both would work. I did the tan of the theta of 25 degrees equals the opposite divided by the adjacent. I found the adjacent to be 95.16. If I multiply both sides by 95.16, I can cancel this. The tan of 25 degrees came out to 0.466 times 95.16. I get 44.37. Yes, sir. No, not a problem. No. It just because this, you got a different number, maybe because of different amount. Look, I only went out 3 digits. I could have went out more digits. As long as I can see you did the math correct, if you come out 100ths or 10th off, I don't care. But look, I did a Pythagorean. And isn't this your hypotenuse leg, which is c squared? So c squared is 105. I called this a square, and I called this b square. So I square root them, or I square them, forgive me. I found out what the number was, and you have done Pythagorean before. And then I subtracted this so that way I can get b squared by itself. I square root it, and look at my numbers.
The first one is way easier.
The first one to me was way easier. I personally like SOHCAHTOA. You can pick either way to solve it. I personally like SOHCAHTOA. Mr. Smith, what did you use?
I use sine.
You used sine. Okay, did you get something close to this?
I got 44.1.
Look, sounds amazing. Sounds amazing. What happened, Mr. Shannon? What's he mad about?
Ryan wants to call me dumb, and I told him
He saw your work. He saw your work and copied it and said he did.
No, I didn't. I told him. I'm gonna tell you what I said. okay?
What'd you say?
He don't like me to be right.
Okay. What did
And
you
so
say?
I told him, if you think about it, we already have the C,
Yeah,
right? And we
Okay.
already have the A,
yeah,
right?
yeah.
So I told him, what if we just go C squared, right? C squared minus A squared equals B squared, right?
Yeah.
And then that's
Square root it.
square root it.
Square root it,
Exactly,
square
that's
root it.
exactly what I did. That's
Not
exactly
what he
I explained.
said.
That's
You
fine.
know what?
He just don't
That's
like me to be
okay.
right. It's okay.
Whether they're haters, they're still fans.
I know.
You know what I mean?
I'm not a fan of someone that does 6 picks in 4 games.
Whoa.
You leave him alone.
I've also thrown, hold up, wait. I know, he got me messed up,
Oh. Uh-huh.
right? I've also thrown 13 touchdowns,
Oh.
right?
Okay. And how many touchdowns did you make personally?
Personally, 5.
Oh. Wow.
Yeah.
Wow. Now, again, remember, those haters are really fans just in disguise. I'm surprised y'all's friendship is still alive.
Oh, that's because we're not.
Oh, we're not friends. We're associates.
No, we're not weak-minded.
Oh. I feel like I want to pause this, but just watch where your zippers are located. Yeah.
That did not sound right.
Zip it, lock it, put it in your pocket.
Oh,
No, come on, man. Get it together.
no. Oh.
I can't wait to answer this test. Oh. I
Yeah.
was like,
Yeah, let's don't say that on video. Yeah, let's don't.
Wait, if we wanted to, can we like
I'm listening.
practice these ones for the quiz? The ones on our notes?
If I was you and y'all feel a little iffy, why not just print out those pages from the tutoring center, since we've already done it, and practice them again? Do you see, does that make sense? Like,
Yeah.
print them out again
Wait.
and practice them
Oh, the ones we did.
of
Wait,
what
you
we've
don't want us
done.
to do the ones we didn't do?
Well, I would say do the ones we didn't do either, but
Oh,
I would
okay.
still practice these 2 pages for quiz day. I would dramatically practice those pages for quiz day. Here we go. Here's the next topic. This next topic is going to cover homework number 4. I need us to pay attention, and I need us to really lock in right now, because if not, then you're going to go home, you might have to cry, and then you're going to email me at 10 o'clock tonight, and I'll be busy. I'm busy tonight. I don't got time to email you back at 10:30 tonight.
What are you doing tonight?
I've got a rodeo committee meeting to do, so I'm be in Houston. I'm busy. We got to prep and get ready for that. So, not until March, but the meetings start today. So I'm gonna be busy. So let's pay attention. I'm recording now, and I recorded 8 a.m. class. Okay, so let's focus, because this is all going to hit. One question like this is going to be on the quiz. Quiz number 2 is going to be nothing but this, pretty much. Okay, one question from this is going to be on the quiz. So let's go ahead and get ready. Projectile motion. Remember what I just did earlier with those markers? I tossed them, I dropped it, I threw it, and I even kicked one. All of those are example of what we call projectiles. Now, when a projectile is occurring, the shape of a projectile, like when you are going to toss the football, is a parabola. Oh man, I start to look at those parabolas on football games. What kind of parabola? What kind of basketball did you shoot? Did you make a nice parabola? What kind of parabola is it?
arc on that front.
Yeah, exactly. Got to get a nice good arc on that. What type of parabola? Now, did you do the calculations in your head to make sure that you threw it hard enough so that way it has enough velocity to make it to where it needs to go? You've got to do that math in your head. Now, an object that forms this parabola, we call a projectile motion. A projectile motion is an object that is moving in 2 directions. What do you mean 2 directions? Well, if you throw a football or throw a baseball, not only is it moving horizontal, but it also is falling down. If no one was to catch it, it would eventually fall down and hit the ground because it's moving in 2 directions.
What if I like threw a basketball off a cliff?
It would still move sideways and it would still fall
I
down.
have one question, I'm sorry.
Mhm.
So like, you know how you said like, if it's like past the point, like say if I was standing on a cliff,
Mhm.
but I have a question like.
What if it was never
if I
tossed up?
if I'm standing on a cliff and I threw the ball down,
Mhm.
like it didn't go in the air, would it just stay negative? Oh my gosh, okay.
Okay.
I swear I didn't even see that.
Okay, so that's next. So that's what we're talking about. We're talking about objects that are in motion like that. Now, these 2 directions, what did I just say a minute ago? It's moving not only sideways, which is in the X direction, it's also moving up and down, or down, which is in the Y direction. So we're going to call this X and Y axis. It's moving sideways and it's moving vertical. Okay? It's moving in 2 directions at the same time. And that is key because we're going to have to need time in a moment. The next part here says that objects that are, for an example, thrown or launched into the air and are subject to gravity. Oh, wait a minute. We know that number. It is on the formula chart, but we definitely know it, of negative 9.81 meters per second square, are called projectiles. For an example, let's just say you hit a softball. Oops. A softball. Let's say, for an example, you release an arrow from a bow and arrow. You throw a dart. You shoot a gun and a bullet comes out. You jump or throw something off of a cliff or off of a building. A clown was launched from a circus cannon. All of those are examples of parabolas in motion. Now, please don't get me wrong. Traditionally, we would have, with air, it would take a shorter path. Because the air molecules are going to slow it down. Yes, sir.
We're talking about,
Give it to me, Mr. Smith.
you said the air doesn't affect it that much. That looks like a big gap.
It does look like a big gap. I agree. For those of us who are, this is without air, no air, no air. It's going to have that longer trajectory. Give it to me. Yes, Ryan.
I was gonna say, I was thinking about that too. When I was driving here the other day, I was going like 75, and that wind was pushing, like, it was strong. It was literally pushing my car over.
And so I agree that air does take into effect. For those of us who want to go to be a pilot, who want to go work at NASA, for those of us who want to be engineers, later on, you are absolutely going to take these air molecules into account. Because, I mean, you want your spaceship, you want your airplane, you want your car to be aerodynamically good. You want to take away as much friction as possible. Because if you increase friction, what do you need to also increase? The amount of fuel. Because it's going to take more fuel or more energy to correct that air resistance. So all of those do take into account. You need to think about those later on when we build our car. Is your car aerodynamically correct? Does it have friction? Because we don't want to go without friction. If we don't have friction, friction's a good thing. Kind of like pain is a good thing, right? Those little kids, when they're small and tiny, they know to not touch that hot stove. Or touch, you know what? Go ahead and touch it. It's going to hurt. It's going to sting. You're going to learn your lesson to not do it again. Now, if we don't have friction, then that's actually kind of not a good thing. I need some friction. Where do we have friction in your car that you want friction? On your tires. You want that friction. So when you build your car, you do need some friction because it's going to help grab so you can go forward. Okay, so all of those do are important, and we do take into account. But at this moment, right now, with us taking this first beginning physics class, we know that all objects that are traveling in a parabolic motion do collide here on Earth with these air molecules, but the collision isn't really that dramatic enough for us here in College of the Mainland Physics to take into account. Later on, you could. Now, I do agree, because of the collision, they do take a shorter parabolic path, which is not that perfect path. Okay? It's not perfect because there are some air molecules. But for the purpose of this class, we are going to ignore the air resistance, and we are going to assume that all paths or trajectories are going to be a perfect parabolic path. Now, these objects, remember earlier when I kicked it, I threw it, I dropped it, all of those markers were considered to be in what we call free fall. The great thing about free fall is that we know that the initial velocity, remember the top of that path of that one example that we did with the bullet? When it was at the top, the velocity was 0. which is good because now that's the number that we're going to take with us with all of these problems. Now this part, some students forget about this section right here. So I'm going to go ahead and just highlight this section because I don't repeat this section much, but it's important to know. It says here, we will always neglect and ignore air resistance. And because we do that in this class, that means that the moment that an object is moving in a horizontal motion, remember when I threw that marker, it moved sideways and it moved down. The moment that I throw something, launch something, kick something in a horizontal motion in the x direction, it's going to have a constant velocity. Why? Because we are ignoring air resistance. We are ignoring air resistance. Because there is no air. When it moves sideways, there is no air to slow it down. It's just going to keep going. Well, what's going to cause it to slow down then if there's no air molecules? Gravity is going to eventually cause it to go down. So eventually that trajectory is going to fall downwards. Okay? Now in the horizontal x direction, the equation that we're about to use in just a moment.
Is this the one for the 8 or the?
Yes. Yep, we're starting it right now. Is dx equals vx times t. One more time. There is going to be one question like this on the quiz. The rest are going to be SOHCAHTOAs, Pythagoreans. In the x direction, because we are going to ignore air resistance, then we are going to say that velocity is going to be constant no matter what throughout the whole path. The dx here stands for horizontal distance, which we prefer to be in meters. The vx is horizontal velocity. We prefer meters per second, and t is time, which is seconds. And take a glance up here. T doesn't have an x on it. I don't care if t is in the horizontal direction, if t is in the y direction, or in the vertical plane. If you can go and think about planes in math class, you've got this plane. I don't care if you have this plane in the z and at an angle. It doesn't matter at which orientation. T is t. It doesn't matter where t is located at. Okay? Now, these are all examples, and this is what Ryan was talking about earlier. These are all considered to be a parabolic trajectory. This kid right here is on the top of a cliff, and this object looks like it is falling straight down. But believe it or not, it's a very tiny parabola. This, look how little this parabola is. There's not much of a width here in between it versus this parabola. You want your runner, if you're throwing this football, doubt it. This, I'm gonna, if we had to make one up, that's what it would look like. It's a half, this is a half a parabola. This is a full parabola, a full parabola. Yes, the width of the parabolas are different, but this is still a parabola. Now, do you remember with those vector arrows with the bullet? This first one right here is missing this half of the parabola. This is just showing me both of the vector arrows for this part is moving down. This one has two parts of the parabola. We have it up and a down, and then this side is down and down. But it doesn't matter. All of these have that same top location where velocity is going to be 0 at the top and acceleration is going to be negative 9.81. Now, all objects are going to fall at or towards the ground at the same rate. All of these right here are going to fall at the same rate, as long as they're launched from the same height. Here's another example or another picture. I've got one ball falling straight down. I have one ball that's launched, but can you notice they're from the same height or the same location? They will all fall at the same rate. This same rate is going to be gravity, and because we're on Earth, negative 9.81 meters per second square. It does not matter whether it was dropped, like this picture up here. See how this one was dropped versus thrown up, or thrown wider out. As long as they're from the same location, they will actually hit the ground at the same time. Did I ever use the word mass? Nope, never used the word mass so far. Never used how much it weighs yet. We've never even used that variable. I don't care if this was a golf ball and this was a basketball. Okay? I don't care. Oh, what if this was like one of those medicine balls, like at the gym, like a big heavy ball? Okay? There you go. It doesn't matter if you dropped one down and you launched one. As long as they're from the same location, they will hit the ground at the same rate, because gravity doesn't care how much your mass is. We haven't even used that word yet. So here is where we're getting to our 8 variables. That was just 3 of the variables. I'm going to go ahead and write those down here again. Here's the horizontal again. There are 3 variables. We have dx equals vx times t. And if we're talking about the vertical, because any object that's a projectile is moving in 2 directions, horizontal and vertical at the same time, this equation is dy equals viy times t plus 1/2 at squared. Wow, that looks familiar too. Yeah. It's our kinematic equation that we've already used. Does this look familiar? This one is actually v equals d over t. It's just rewritten in a different way. It's the same equation. This is not given to you like this on the formula chart. This is given it to you in this format. It doesn't look like this. So it's this equation just rewritten in a different way. If you don't like this, then use this equation. They're the same one. They're the same one. And it says here, since velocity is constant in the x direction, that's what I highlighted up here. Horizontal is the x direction, and acceleration is constant in the y direction, which is gravity over here. Then there's only a few variables that we do need to figure out. And did you notice that on this one over here, right here, there's nothing under t. Both of those t's just say t. Why? Because it doesn't matter if t is in the x or y direction. So let's practice. Okay. You are going to have one question, only one like this on this quiz. That's it. But this is all of homework number 4. You have to try it. I'm not expecting you to be perfect, but you have to try, and we will go over the homework before you take the quiz. Okay, so let's practice. There is this bridge in Colorado, and it's 321 meters above the river. That's how tall this bridge is. Suppose you are at the top of the bridge and you're going to kick a rock off of the bridge. What's going to happen? It's going to go, and it's going to hit the water below in such a magnitude that it falls 45 meters from the bridge. Wow, how hard you kick that rock? Pretty freaking hard. Find the speed at which you kicked the rock. Now, I'm not going to lie to you, I'm a little overwhelmed. When in doubt, let's draw it out. So let's do that first. You are standing here on this bridge, and look, you got your foot back because you're about to kick this rock. Do you see that foot is back? Because you're about to kick it. You're about to just go over there and just give it a good kick. Now, obviously, this rock is going to go like this. It doesn't. But remember, my drawings aren't to scale.
Maybe you just so high the perception of it.
Yeah, because you're so far away.
Exactly.
And it's so high, you can't, yeah. But this is going to be kicked out right here, 45 meters away. And the bridge is 321 meters above. Now, not the scale of the drawing, but the drawing itself at this moment looks like it's pretty correct and labeled pretty correct.
Yes.
Okay, at least it's a myth. Now, here's the number one misconception. I get students that look at this, and the first thing they see is a right angle, and they want to try to SOHCAHTOA. We cannot SOHCAHTOA. Here are two clues on how you cannot SOHCAHTOA. Clue number one, there's no theta. There's no theta. Clue number two, it forms a parabola. Okay? Clue number one, there is no theta. Clue number two, it forms a parabola.
So that's how we know that. Wait, when we're reading, how do we know that it's not SOHCAHTOA?
Because there's no theta degrees involved. There's no angle.
Okay.
And because there's no angle or theta, and when I drew it out, I made a parabola. Well, to be honest, it's only a half a parabola, Miss Munson. I agree, but it's still a parabola. My question is, how hard was this velocity? How hard did he go and kick it? I don't know. Let's figure that out. Now, when you get to this point and you know that is not SOHCAHTOA, then you are going to do this. You're going to do a T-chart. And you are going to write down the 8 variables from these two equations. Let's list our 8 variables. There's 8.
I always see 3.
Oh, no. Let's look. There's dx, there's vx, there's t. That is in the x direction, which is horizontal. In the y direction, there's viy, vfy. These are the same ones that we've been using on the kinematics. dy, t, and a. And if you want to, you can call it AY, if you really want to. 1, 2, 3, 4, 5, 6, 7, 8 variables. That's 8 variables. Okay, remember, this is big kid physics now. Let's fill in our variables. In the x direction, which is sideways or horizontal, and the y direction is up and down vertical. Do you see how I did it in 2 different colors? So here we go. Horizontally, the distance is 45. Horizontally, my velocity is my unknown variable. Was t ever mentioned, talked about, discussed? Nope. Let's go to the vertical side. Do I have a vi in the y direction? Yes, I do. I told you that on the previous page. When we have a parabola, and at the top of the parabola, it is called non-zero acceleration location at the peak, and velocity is 0. Velocity is 0. Did I get a VF? How hard it hit down? I don't know that. I'm gonna put an X. Do I have a distance in the Y direction? Yeah,
Yeah.
321. How about a T? Never talked about. Do I have an A? Gravity. Thank you, because I was about to throw something. Negative 9.81. Okay, here's what I personally do. Because I'm a visual person, I have to see it so I can learn it. And I'm going to come over here. I'm going to highlight this side because I get overwhelmed. Personally, I'm going to highlight the side that I need. Now stop algebraically. Could you solve for an algebra problem if you're missing 2 variables? Nope. So this tells me that I've got to solve for something over here first that I can plug in over here. Yes, sir.
So if you have vertical and horizontal time.
I do. But what did I say earlier? T doesn't matter if you're in the X, the Y, the diagonal, whichever plane you are looking at. T is T all over the place. So if I say, oh, wait a minute, here's the rock. I'm about to kick the rock right here. Here's the rock. I'm about to come over here and boom, kick it. The moment that it's launched off of this bridge, you start the timer. That T is going to be how much time it is in the air, whether it's in the X direction or Y direction. It's going to be in the air for T time. I don't know. That was never given to me. I X'd it out. But do you see how T in the Y direction doesn't have a Y? The T is the one thing that we can plug in the Y, and we can grab it out of the Y and go put it into the X. That is the only variable that, here's what we call it in physics, can transcend on both sides. One more time, in physics, we say that T can transcend on both sides. We can get it from this side and plug it in over here, or we can get it from over here and plug it in over here. Go ahead. It's kind of like, you ever have that one friend that hangs out with this group and that group, and that friend can go from group to group. It's not like they only belong in this group or they only belong in this group. They hang out with both groups. And that's what the T is. That T is that one kid that hangs out with this kind of group, but yet also hangs out with that group of kids. So let's go ahead and do this. It's a 2-step problem. We are going to solve for T in the Y direction. And remember, I gave you the equation on the previous page. dy equals VIY times T plus 1/2 AT squared. Now, before you freak out, what did I say the VI is always, always, always going to be? 0. So look at this. We get to cancel that first part out every single time. I like canceling things out. Cancel it.
Ms. Munson,
Yes.
if we know we're going to cancel that out every single time, why do you do that?
I do it in the beginning for some of us, because some of us later on, it might be too much. So I do it, but later on, you're right. Like next week, I'm not going to even talk about it. There you go. So that is my equation right here. Distance, 321 equals 0.5 times, listen to me, because people are going to get mad at me. This is a negative 9.81. The negative only means direction. I truly should put a negative 321 because the rock started at the top of the path and is falling down, which is truly a negative direction. I'm going to kick this negative out because I don't need it. I know its direction. 9.81 times t squared. 9.81 times 0.5. I need to divide that and get it out of the way. So 0.5, 9.81 cancel that on this side, 0.5 times 9.81 equals t squared. Not my answer. It actually equals 65.4. I agree. Let's square root it. T equals 8.808. T is 8.08. 8.08. There we go. Part 1. Part 2. dx equals vx times t, or 45 equals vx times 8.08. Cancel 8.08, divide 8.08. The velocity in the x direction. How hard did this person come up and boom, kicked it? Comes out to a velocity of blank meters per second. You got a calculator, figure it out. Come up with the answer. Shelby, what'd you get when you got it? Oh, okay. Sounds like, I forgot to charge my cell phone.
I got 5.57.
There we go. Looks good to me. Let's practice this again. You're gonna have homework and you're gonna have a quiz with one of these questions. Mr. Smith, give it to me. Josiah.
How do we get rid of the negative on the gravity for
On part 1?
Yeah.
Okay, so on part 1, is the question, why did I get rid of it, or how would I get rid of it? Both? Okay, I got rid of the negative on part 1 because negative only is a direction, not like you owe me $9.81. Since it's just a direction, I kicked it out because it's of no value to me. It's just showing me the direction, so I kicked it out. But if you have a negative 321, and then you had a negative at the bottom, a negative divided by a negative would equal a, there you go. That's how mathematically, if you left it in, because it's moving in the down direction, which is a negative direction. If you want it to be politically correct regarding physics-wise, that's what you would do. Alrighty, let's do this again. Shelby, do you want number 2 or you want number 3?
3.
Let's do 3. Okay. 3 is a ball. And here we got one right here. The ball is on the table and it rolls off the table. You've seen something like this before, right? In your lifetime, a ball is rolling and it, boom, falls off of a table. Okay, let me draw this table. Here's a ball. It's rolling at a speed of 2 meters per second. The distance of the table is 1 meter above the floor. 1 meter. How far does this ball land on the floor away from the table? Question mark. What is this distance in meters?
Wait, so do we have to memorize all 8 of the meetings?
I don't think it's necessarily memorizing. It's the same variables that we have used in our equation. So for an example, we're going to use this equation and this equation. So because of that, those are the 8 variables that we're going to use. The only variable, I guess, this is a really good question. Ms. Munson, do I need to memorize the variables? You kind of don't. The only variable that's not labeled is VF. And here or here, it's not labeled. But just in case if the question asked you what was the final velocity, that's the reason why I toss it in. So I toss it in just in case. I don't want nobody to throw a trick question to me. So number 1, do I see a right angle right here? Yes, but it's not SOHCAHTOA. Why? Because there is no theta talked about, and this is a parabola. Okay, it's a half a parabola, but it's still a parabola. So we're going to X and Y T-chart this. Here are my equation. dx, vx, t. What are my kinematic equations? VIY, VFY, dy, and I agree, A and T. I agree 100%. Now, I'm going to go ahead and put in what I do know. I know the distance in the y direction of 1 meter. I also know that in the y up and down, the velocity is 0 and A is 9.81. I do know the velocity horizontally is 2. The distance horizontally is my unknown. T was never given to me. VF was never given to me.
How do you know that A is always positive?
Yep, it is always gravity because gravity's touching it. I am looking for the X location or the X variable in the distance. Could I solve for it? No. Find T in the Y, plug it into the X. Step 1. dy equals VIY times T plus 1/2 AT squared. I agree. VI is always 0, so I'm going to cancel that out. The distance in the Y is 1 equals 0.5 times gravity times T squared. I've got to get T by itself. Divide by 0.5 times 9.81. That cancels. Divide by 0.5 times 9.81. This is T squared, not my answer. So I've got to square root it to figure out what T is. 0.45 seconds, not even my answer. I'm going to put it over here. Now I can solve for this distance of where it's going to land on the floor. Part 2. dx equals vx times t. The distance I do not know. The velocity is 2, and the t. This t tells me how much time this ball was in the air. It was in the air for 0.45 seconds. Multiply those two numbers, and you're going to find your distance on your own. That is all the notes that we are doing today. Whew. One question will be on there. Now, I want to go over a couple more things. Yes, come on. Take a glance at, I've got a little bit more time, homework number 4. Now, we are absolutely capable of doing homework 4. I want to look at question number 1, because question number 1 is a good question. A construction worker drops a wrench off of a pier. Okay, so they're on this bridge pier thing. And this construction worker has a wrench. Obviously, remember, my drawing's not to scale. But what's going to happen is they're going to accidentally drop it. It tells me that it hits the water in 1.8 seconds after it was dropped. Because we're on this pier. There's water below. How high, question, was this pier up here? How high up? How high was this bridge or this pier? Well, I see a parabola, so it's x and y axis. dx, vx, t. viy, vfy, dy, t, a. I'm actually looking for how high up, so I'm looking for the y-axis, but let me plug in what I do have. I have 1.8, 1.8, 9.81, vi of 0, never gave me that. That's my question part. What side am I looking for, the x or the y? Y, I agree. I'm looking for the y. The equation for the y is dy equals viy times t plus 1/2 at squared. I'm looking for the distance. vi is 0, 0.5 times 9.81 times, do I have t? I do, 1.8 squared. dy, the distance of how high up this bridge or pier was, multiply those three numbers together. You can so do this. Remember, what makes it a two-dimensional kinematic? It's in the air falling. It's in free fall. And it's moving in what we call two directions, in the x and in the y axis at the same time. It's being launched. It's going to form a parabola. Okay, so here we go. You've got homework number 4 to work on. I just did question 1. I videoed it. Oh, look at this. We got a kicker from a football game over here. So we need to practice those questions. Other than that,